Pascal's law. A magical principle, by which a little force is sufficient to lift a huge weight. This is not just a theory, but it is practically used in a variety of applications, from our day-to-day life to large industrial applications. Let us understand the science behind the Pascal's law in detail with Sci Joe, simply the science. Let us start with the base theory of Pascal's law, with the explanation. When a liquid is confined, and an external static force is applied to the liquid at any point, will generate and transmit an equal pressure throughout the liquid. In simple, everywhere in the container, pressure will be constant. Then getting into the common apparatus that helps us understand Pascal's law in detail. Let us fill a liquid in this container. And if we put a leak-proof piston, such that confining one side, due to this piston's self-weight, the liquid gets displaced, but we cannot experience Pascal's law. So, to completely confine the liquid, let us put another leak-proof piston on the other open side. Also, let us add some more elements like the stopper plates, the green color items, and a test weight that needs to be lifted. Now, if we place a comparatively smaller load on this side, it lifts up the test weight. But what is the magic behind this? Basically, what is the theory behind this? To understand and visualize the concept, we should scientifically know what pressure is. So, what is pressure? When a certain load is acting over a given area, the pressure will be generated between the surfaces, and the pressure can be said to be the load per area. For example, if a 100 kilograms load is applied over the area of 1 square meter, then the pressure will be equal to 100 kilograms per meter square. Having said this, let us get into our apparatus. By adding a load, it generates pressure between the piston surface and the liquid contact surface. Then, as stated in the principle, this pressure transmits equally throughout the liquid in the container. For the calculation purpose, let the left side be side 1, and the right side be side 2. So, we can name the pressure on side 1 as P1. Correspondingly, the load and area may be named L1 and A1 respectively. Similarly, side 2 will have pressure, load, and area as P2, L2, and A2 respectively. So, the equations stand like this. We know that the pressure throughout the container is equal. Meaning, we can have a common notation for the pressures on both sides as P. Because P1 is equal to P2. So, it can be further written as L1 divided by A1 by replacing the P1. And L2 divided by A2 by replacing P2. So, the equation goes like this. Now, let us test this with some maths. Consider the load to be lifted to be 30 kilograms. And that will be L2 in this case. Let area 1 be 5 square units and area 2 be 15 square units. That means A1 will be 5 and A2 will be 15. To find out the value of A1, we need to do some mathematical arrangement of the equation like this. Finally, by doing this math, the L1 could be found as 10 kilograms. This means a load of 10 kilograms will be sufficient to lift 30 kilograms load if the area is increased by 3 times. And if there is a requirement like, with 10 kilograms load, a load of 300 kilograms is to be lifted, then a 30 times increase in area is required. In summary, the pressure remains constant throughout the container. This helps in manipulating the forces, or loads, between locations, by modifying the sectional area. Pascal's law is widely applied in automobiles and manufacturing industries, and many other areas including the common man's daily life. Some examples of Pascal's law's applications are car brakes, car lifting mechanisms, earth movers, forklifts, pipelines along with water tanks, saloon chairs or office chairs, and more. To avoid dragging the time, I'm just expanding one of these examples. A forklift. It lifts and downs the components, using hydraulic cylinders, with a hydraulic system. If you wish to know more, in detail about any of those examples, just drop us a comment. So that we will try our best to make the next videos, explaining your queries. The same concept, but a different horizon. How a nail gets into wood or wall, only if it has sharp point? Why it is not getting into the object, if the point is blunt? Similarly, why does only a sharp edge of a knife slice a vegetable? What is the science and engineering behind this? Let us answer and understand all these questions in our next video. Ensure you hit the subscribe button to get this and similar videos to reach you without delays. If you feel this video helped to enhance your knowledge, please do let us know by giving us a thumbs up. Thanks for watching. See you soon.